Welcome to Citizen Science, stories of science we can do together, brought to you by SciStarter. This episode is all about the science of the sun in honor of the Heliophysics Big Year. Learn how you can help scientists better understand our favorite star. Hey, it's late September and nearly time for the autumnal equinox, when the sun sits right over the equator, which means that daytime and nighttime are the same all over the world, 12 hours each. That's what equinox means, equal night. Actually, day is a bit longer because after 12 hours, that's when the center of the sun goes below the horizon, but it's still pretty light out then until the whole sun is set, but pretty much equal. But this equinox is different from all others because it precedes the Heliophysics Big Year, which is just about to kick off. 1 year of solar-centric celestial and Earth-based phenomena and research activities starting in October 2023 and running through the end of December 2024. And yes, that's actually more than a year, that's 15 months, but there's a reason that it's starting in October instead of waiting for January, and I will share that in a bit. But first, I need to start out this podcast with a short segment for smart dumb or dumb smart people like me. If you're a smart person, you can hang out and laugh at us and me, or just skip ahead a few minutes. But if you're anything like me and you're a visual learner, you learned about the solar system through textbook images showing the sun and all the planets laid out in a line across the page with a big sun, a little Earth, a littler moon, big Jupiter. Maybe there was like a pull-out page to fit everything in, but everything did fit. And if you looked at that, and then you were given, say, like a little marble to represent the Earth, and I apologize to folks listening to just the audio podcast because you can't see this, but I'm holding a tiny little marble. And so if that's Earth, and then say this pin is the moon, and I've got one of those pins they use to hold together, fancy packaged dress shirts. Going by those pictures in the books, the moon is maybe like an inch or so from the Earth. I mean, it's like that. And those physical models of the solar system called orreries, would have all the gears and the celestial patterns and all that stuff. They're even worse. The sun and the planets and the moon were like totally smushed together. So then, say a teacher explains that the full moon happens when the Earth is right between the moon and the sun. And you're like, that doesn't make any sense. If the sun is like over there, and the moon is behind the Earth and it's this close, the moon's going to be right in Earth's shadow. So there should be no such thing as a full moon. There should be like a lunar eclipse, where the moon passes behind the Earth each month, right? And solar eclipses, those are even worse. That's when the moon completely covers the disk of the sun. But if like the Earth is the size of this marble, the sun would be the size of this big exercise ball, actually even bigger, but I'm just working with what I got here. And a shadow from like a pinhead-sized moon like that wouldn't do anything there's no way it would blot that out entirely, blot out the sun. So none of this eclipse stuff really made any sense at all, because those illustrations are like totally wrong. And yes, I know they have notes saying illustration not drawn to scale. But that is not enough, because for real, drawn to scale, this pinhead moon needs to be way like over there, like about 2 feet away from this little marble Earth. Can you still see that? Oh, I went right out of frame. Yeah, like that, okay? And the other thing we're never taught is the moon's orbit around the Earth isn't straight and flat. It varies up and down like about 5 degrees, which when you're this far away is a lot. So here's the moon. The sun's like way over there shining on it, right? And the Earth's shadow is like down there, not causing any trouble at all. So people here on Earth, on this blue marble, can see the full moon. Or the moon's down here like 5 degrees, same thing. Only once in a while does it fall right into Earth's shadow, and that's when we get a lunar eclipse. So if this is the Earth, this is the moon way over here, and this exercise ball is the sun. So how far away do you think that exercise ball needs to be from here to be in scale? Like way on the other side of the room? No, 2 football fields away, almost down to the park at the end of our street. So you still might be thinking, yeah, but even so, is this little pinhead gonna totally cover that exercise ball? Well, yeah, it is. If I hold this pin about 20 inches from my face, so my face is the earth and this is the moon, and then I have that exercise ball 2 football fields down, this exactly covers the exercise ball, exactly like the moon during a solar eclipse totally covers the sun. And by the way, if you want to see the scale of the solar system depicted way better than I am doing here, check out Wiley Overstreet's short film called To Scale the Solar System. It's a film I really wish I had when I was a kid. All right, that's it for now. Smart people, you're welcome to join us again. Come on back. So the Heliophysics Big Year starts in October instead of in January because in addition to a total eclipse of the sun on April 8th of 2024, there's something called an annular eclipse of the sun happening on October 14th of 2023. And it would be cruel to not include that in the Heliophysics Big Year. The annular solar eclipse is called the Ring of Fire eclipse, not because astronomers love Johnny Cash, but because the moon's orbit happens to be a bit further from Earth, making the moon appear to be a bit smaller, so it doesn't completely obscure the sun. It leaves a ring of the solar disk still visible. All right, finally, in addition to the annular eclipse in October and the total eclipse in April, we're now approaching what's known as the solar maximum, which is the point in the sun's 11-year cycle when its magnetic poles flip and when it's most active. There's more solar storms and flares, and some of these can actually affect Earth. Now, getting the public aware of all of this and publicizing the many NASA-based activities surrounding the big year is itself a big job, and that's what our first guest is taking on. Hawa Hamano is Presidential Innovation Fellow at NASA, working on citizen science activities. I spoke with her at the CSci Citizen Science Conference in Tempe, Arizona. So what's happening? I know we got some eclipses coming up. How's NASA involved?
Yeah, so I think for us, it's really thinking about it from a human-centered way. When folks think about NASA, it's just NASA, you know, and it's not these necessarily, they don't necessarily know how to get in directly into these different projects. And so we're the front door to say, hey, what is it about the sun? What is it about space? What is it about your environment that you're interested in? And we can divvy out and show you a lot of different on-ramps to what it is you're interested in.
Okay, and for example, what is this that you just handed?
Yeah, so this is our zine project that we are trying to get folks kind of a very quick and easy way to put NASA science in your hands, right?
Okay.
And to really develop it on their own. So when we talk about the science, the scientists that I work with are so excited about their science. They literally write, these huge papers on it. How can you distill it down into these small portable zines and put it into folks' hands? And taking it even further, for them to write their own zines and to create their own zines. When they hear all of this really exciting scientists telling them all the wonderful phenomenon that they're studying, they can go down and say, okay, well, this is what was exciting to me, and then hand it on to their friends so that it is this personal connection to the science.
Wow.
That's a little.
And where do we get these zines?
They'll be available online. I think what's really exciting and what we really want folks who work with communities is to actually do the zine activity themselves. So you have all this information on nasa.gov, on podcasts and ways that scientists are out in the community, and really to have them do this activity on their own. And so that's what we're excited about, is for you to create your own NASA science zine about the Heliophysics Big Year.
Neat.
Yeah.
Wow. And not to get all like woo-woo about it, but it's like the sun, centuries ago was like the center, the Apollo, the sun god. It was a really big part of culture and their society.
Yeah.
And then it seems like, oh yeah, the sun, we got artificial light and we got other forms of energy. We didn't rely on it. We sort of forgot. And it's something like this with an eclipse that maybe kind of reminds us how important, and it affects animals. It affects us. It affects, I guess, communications.
Radio waves. That's right.
Yeah. So it's kind of not full circle. It's not like we worship it or something, but
no.
But it's kind of bringing it all back
Yeah.
and showing us how important.
Yeah. Our science folks talk about, the sun as an ordinary star, right? And it's like, yeah, it's just kind of your typical star. A lot of my astrophysics colleagues like, that's great that you study one of the stars. We study all the stars. It's kind of like an ordinary.
We win.
Yeah, other things to look at. But I think what us heliophysics us in heliophysics like to say is it is an ordinary star, and the only one that we know that gives life, right? And so that is, and it's so close to us, and we can study, and there's so much that we actually don't know about it. And so it's our special ordinary star.
Great. All right. Thanks so much.
Thanks, Bob.
HowWow will be sharing 19 different citizen science projects for the Heliophysics Big Year, helping to get the word out and get the public involved in research projects that need their help. One of them is called Citizen CATE, C-A-T-E, and that stands for Continental America Telescopic Eclipse. Citizen CATE principal scientist is Amir Caspi at the Southwest Research Institute. Hey, Amir, thanks for joining us.
Oh, thanks for having me, Bob.
All right, so Citizen CATE. This sounds like a really cool project, gets a lot of people involved in a very deep way, it sounds like. So tell us about it a little bit.
Okay, so Citizen CATE 2024 is a community participation experiment to do professional level science, but with volunteers from communities who live all along the eclipse path for the total solar eclipse that's happening across the United States from Texas through the Midwest to Maine next year, April 8th, 2024.
So what are you looking for? What are the people going to be doing?
So we are actually performing a scientific experiment. We want to study the sun's outermost atmosphere called the solar corona. Normally you can't see it. It's so dim, and during the daytime when the sun is out, you just can't see it. The sun's too bright. But during a total eclipse, the moon perfectly covers up the disk of the sun, and it blocks out all of that bright light, allowing us to see the solar corona, which is about as bright as the full moon. And of course, you can look at it with your eyes. It's one of the most spectacular sights that a human can ever behold. It really, truly is. It's hard to even explain what a total solar eclipse looks like. But it's really important to us scientists because it lets us study that solar corona in ways that we just can't do any other way outside of a total solar eclipse.
No, I was going to say, and why is the corona so important? Why do you want to study it?
Well, so it turns out there are a lot of interesting questions about the corona. You know, people forget we live around a star, right? I mean, the sun is a star. It's an astrophysical object, and we live around it. And a star has this corona, and one of the really interesting things about it is the corona is actually 100 times hotter than the surface of the sun. Okay. It's really weird. It's like you walk away from a campfire, but it gets hotter as you walk away, right?
So weird, yeah.
The surface of the sun is a few thousand degrees Celsius, but the corona is millions of degrees Celsius. It's basically as hot as the core of the sun. And how does it get that way? Well, we know that the energy is deposited by the magnetic field in the corona that we can't actually see, but we know it's there. And we want to understand how that energy goes from the magnetic field into the plasma, the hot ionized gas that fills the corona.
Huh. And I was going to say, and that helps us, that affects Earth sometimes too, doesn't it? Doesn't the plasma, come and interact with the Earth's ionosphere or atmosphere?
Absolutely. Yeah, actually it does. There's something called the solar wind, which is this constant stream of particles that's coming off of the corona out into interplanetary space, where it goes out across Earth, Mars, all of our assets in space. And sometimes that can be a radiation hazard. Sometimes you can have what we call solar eruptions, where a huge amount of material is thrown out into space. And we want to understand how those processes happen also. So during an eclipse, we can actually see a lot of the telltale signatures of how the solar wind is born. And hopefully during this solar eclipse with Citizen CATE 2024, we'll be able to learn a lot about that.
And so let's say I'm one of the lucky volunteers who's selected. I guess I have a little team. And what'll we do? How do we get started? I'm just kind of curious as to what these folks are going to be contributing.
Yeah, that's a really great question. So, normally a lot of these experiments are done by professional scientists, but this particular experiment, we just can't do it with professional scientists. We need everybody's help, because if you're just a single person standing in a single place, the moon's shadow during an eclipse, it actually goes really fast. It goes about twice the speed of sound, about 1,000 or more miles per hour over the ground. So over any one station, totality lasts only a few minutes. But we want to study something that might require tens of minutes or even up to an hour. So how do you observe an eclipse for an hour? It's really hard to chase the shadow. You need a really, really, really fast airplane. But instead, we could make the shadow chase us if we put a whole lot of people all along the eclipse path, and every one of them had cameras and telescopes and laptops and all had the appropriate training to make those observations. Then we can take all of their measurements and put them together into an hour-long movie of totality. So that's what everybody's going to be doing. We're going to give them cameras, we're going to give them telescopes, we're going to give them tracking mounts that will help point the telescopes at the sun.
Wow.
We'll give them computers, and very importantly, we're going to train them in how to use all of that equipment so that on eclipse day, they can go out and make all the same types of measurements at every one of our 35 community participation sites. Then we get the data, we put it all together, and we make this hour-long movie.
Wow, that is so great. And do you have to be like, an astronomer or astronomy student, or, can a regular person do this?
No, really the whole point of this experiment is to make it so that anyone can do this. You probably need to be comfortable around a telescope, but it doesn't matter if you've never used one before. We're going to train you how to use it and how to make the measurements. And anyone can really do it. We're looking for regular people, high school students, university students. They don't have to be science majors. They can be English majors or history majors or anything. We can take Girl Scouts, Boy Scouts, 4-H, people who are members of a public library or members of a museum. Really anybody can participate, and we're looking for a broad and diverse audience to really help us with this. And the really cool thing, as thanks for participating in this experiment, everybody will be compensated with an honorarium to thank them for their time. And their communities actually get to keep the equipment so that they can use it as an educational resource, not just for this eclipse, but much later.
Okay. And of course, you do have to either live or plan to be along this path to participate. So it's not like for everyone in the world.
That's right. We're looking for people who live within driving distance of the eclipse path, because they are going to have to visit the path a few times before the eclipse and then on eclipse day again. So we're trying to prioritize people who are an easy commute away from the path, but we are looking for literally anybody. Anyone can apply, and then hopefully we'll be able to select a nice broad group of folks who can help us.
Great. And so when will that happen? Do you know, if the people that are listening to the podcast want to participate, what can they do?
So right now we're recruiting our sort of state-level, district-level coordinators that are going to help us train and interface with all of the local teams. With 35 teams of people, it's going to be pretty hard for just any one small group of people. So we have this team hierarchy. And right now we're working on recruiting that sort of state level. We're going to be recruiting our local teams around October and November of this year, 2023. Okay. And then they will start to train in January and February of 2024. They're going to interface with their state-level coordinators, they'll receive the equipment, and then they get about 2 months to practice with the equipment before Eclipse Day so that they can be fully comfortable with the equipment, with the procedures, and they can just get into the groove so that on Eclipse Day, everything will go smoothly.
Wow, so cool. All right, well, thanks so much, Amir.
My pleasure. Thanks for having me, Bob.
Well, let's say you volunteered for Citizen CATE, but you weren't chosen to be on one of the 35 teams. There are still 18 other NASA citizen science projects you can join, including Eclipse Soundscapes, where volunteers listen to the eclipse, record it, and learn how it affects the aural environment. Mary Kay Severino is co-lead of Eclipse Soundscapes. This sounds sort of interesting. It's an eclipse, but we're listening to it. It's soundscapes. So can you explain what the project is all about?
Sure. So we are thinking about eclipses from a multi-sensory perspective and thinking about science from a multi-sensory perspective. Observing and collecting data doesn't have to be just using one sense. We can think about what we feel, what we hear, what we see, and eclipses are no different. And sometimes events that are perceived as visual events, we only think about what you see during eclipse, but there's so much more. Animals start to believe that it's night, so how do they react? What sounds do they make? What sounds do we make as people? We get really excited during eclipses. So we're going to be collecting sound data during the entire eclipse week to get some data before, during, and after the eclipse. And we really need citizen scientists to help us with that. And we're also going to be collecting qualitative data, observations on eclipse day, and we need citizen scientists to be able to help us with that too.
How do we do it? How do we sign up, and what do we do on the big day?
So you can sign up by going to eclipsesoundscapes.org. You can also, of course, go to SciStarter and find us on SciStarter. Those are two great ways to find us and learn more. During the actual eclipse week, anyone who collects data will be putting out a small recorder about 2 days before, and then leaving it there and picking it back up 2 days after. There are opportunities to build your own kit. All the information is available online. They're relatively inexpensive pieces of equipment. There's also opportunities to apply to get a free kit if you go to eclipsesoundscapes.org to apply. And something else that I want to point out, we've really been thinking a lot about accessibility and inclusion, and that's a really important aspect of our project. We thought about which community of people has been left out the most from science that's perceived as visual, and that's the blind and low vision community. And so something that we've done is really thought about how can we make sure that this project is accessible from a blind and low vision perspective. And that's not to say that this project is only for members of that community and not others. This is a way for all of us to participate in science on equal footing alongside one another.
And it's a community that probably has more to contribute because, you know, when you're attuned to sound, you might hear things that other people don't hear. You might be aware of things that other people might. You might be, there's even other senses that you might be more, for instance, there's temperature changes, there's other changes. And so it's really taking advantage of an underutilized resource, perhaps.
That's definitely true. And after the eclipses, we're going to be calling on citizen scientists again to help us analyze all this data. So while that information isn't available for sign up yet, it's going to be. And all that information will again be available on SciStarter when that happens too.
Great. And now I sort of had a bias towards the total eclipse, but there's actually more than one eclipse, right? So what are the dates that people can get involved?
There is an annular solar eclipse, and that is happening on October 14th, 2023. And that stretches from Oregon down to Texas. It's about a 125-mile wide path. And then there's, of course, the total eclipse, which you mentioned, and that one is on April 8th, 2024, and that will stretch from Texas all the way up to Maine, and also over a 100-mile wide path. And along both of those paths, you will experience either the annular eclipse in 2023 or the total solar eclipse in 2024, or if you're near those areas, you'll experience a partial solar eclipse, which is also pretty amazing and something exciting to behold, and we could also use data from those areas. So if you're not exactly on the path, we still need your help.
Great. All right, thanks so much, Mary Kay.
Thank you.
You can learn more about Heliophysics Big Year Citizen Science Project at scistarter.org/NASA. In addition to Citizen, CATE, and Eclipse Soundscapes, there are projects where you help researchers study how plasma exploding off the increasingly active sun interacts with Earth's magnetic field. Those projects include Aurora Saurus, Spartacular, and HARP. In others, you study the sun through its radio wave emissions with Solar Patrol, Radio Jove, and the Ham Radio Science Citizen projects. You can even discover exoplanets by looking at stars and seeing if they show telltale dimming that indicates the presence of distant planets partially eclipsing them. That's what you do in Exoplanet Watch and Planet Hunters TESS projects. And there are lots more, so check out SciStarter.org/NASA. Well, that's it for this time. I'm Bob Hirshon for SciStarter. This podcast is brought to you each month by SciStarter, where you will find thousands of citizen science projects, events, and tools. It's all at SciStarter.org. That's SciStarter.org. If you have any ideas you want to share with us, any things you want to hear on the podcast, just get in touch with us at info@SciStarter.org. Once again, our email address is info@SciStarter.org. Thanks.